So we've been looking at solving these systems of equations. We've looked at some applications of them, and I plan on showing you more here in the next couple of classes. But today we want to move on to that next level of having three variables. Now we've kind of gone through the progression here. We started out last semester even looking at a single equation with one variable. Now if we only had one variable, like 2x minus 7 equals 11, we only needed one equation. Well, then we stepped up in the last few weeks. We've been looking at two variables. Something like 2x plus 3y equals 19 and 3x minus y equals negative 1. So when we had two variables, we needed two equations to solve it. And so today, as we move up into three variables,
once again, this is a reminder to all staff and students, do not open up the Google shared document that you are receiving through email. There is a safe life issue with Google, so in the event that you need to share a document with someone, make sure you contact that person that you are going to share it with them. Otherwise, do not open any shared document through Google until further notice. Thank you.
That's hitting you guys too. We just got the notice on that as well. So anyway,
I heard you say open it.
heard him say open it? No.
So I opened it.
It's supposed to be a pretty nasty virus, I guess. So anyway, that was one of the more devious phrases I've ever heard. So anyway, so we had one equation, we needed one variable, we needed one equation to solve it. If we had two variables, we needed two equations to solve for those variables. Well, here now, when we have three variables, we're going to need three equations. Now to make this a little easier here, I'm going to label these equations A, B, and C, so that I can just refer to them quickly like that. Now we had three methods that we used for solving these two variable systems. Our first method we used was graphing. Well, that worked well with two variables, but with three variables, graphing is very, very complex, and trying to see where they intersect is really a chore. So that's not going to be used for three variables. We had substitution, which we're going to look at in just a minute with our three variables. And finally, we had the elimination or addition method, which we're going to look at today as well. Now, when we'd solve these two variable systems here, what we did, either substitution or elimination, was we got rid of one of the variables. We converted that two variables and two equations into one variable and one equation. And then we solved it, and then we used that information to go back and look at the other equations. What we're going to do here for three variables and three equations is our first step is going to be to reduce it to two variables and two equations. Then once we're at two variables and two equations, they'll be just like the ones we were working on last week. So we're going to start out using the substitution method. For the substitution method, just like before, we have to find a variable that's easy to solve for. So we're looking for a variable that doesn't have any coefficients on it. No, it's not multiplied by any numbers. It's multiplied by 1 or negative 1. And if we don't have any of those, remember we looked for variables multiplied by 2 or 4 or 5. Numbers that we could divide by and get neat decimals and not repeating decimals. Well, in this system here, we see that in equation A, the top equation, we've got just z there. It's a 1z. So we could solve that equation very quickly for z. So that's what we're going to do, is we're going to solve equation A for the variable z. So I'm going to write down the equation, 4x minus 2y plus z equals 21. So we need to get z by itself. So I have to get rid of the 4x and I have to get rid of the negative 2y. Well, it doesn't matter which one I get rid of first. In fact, I could get rid of them both at the same time, but I'm going to take it a little slow. I'm going to get rid of the 4x first. So I'm just going to subtract 4x, and that's going to be gone. Subtracting 4x on the other side, I have my negative 2y here, plus z, so none of that's changed. On the other side, I've got 21 minus 4x is 21 minus 4x. Now I have to get rid of that negative 2y. To get rid of it, I'm going to add 2y. This makes that negative go away. I have to add 2y on the other side. So now I have z here equals 21 minus 4x plus 2y. So that is equation A, remember. And I solved it for the variable z. Now, since that was equation A, I'm not going to use equation A again right now. I have to use the other two equations. So I'm going to take equation, it doesn't matter which one I use first. So I'm going to take equation B next. 2x plus 3y plus 2, but instead of z, I'm going to put in this right here, 21 minus 4x plus 2y. And of course that equals 10. So all I've done there is I rewrote equation B, only I replaced z with that expression that I got from solving equation A. So here's my first substitution. I have to now reduce this equation, simplify the equation. So I'm going to look at the parentheses there. Is there anything I can do inside that set of parentheses? No, I have 1's, I have x's, and I have y's. I can't combine anything in there. So what I have to do is, perfect, distribute the 2. So I've got 2 times 21 makes 42. And since it's a positive 42, I'm going to put a plus in front of it, because I've got other stuff I'm going to have to put up there. 2 times negative 4x, negative 8x, and 2 times 2y, positive 4y. Good. So now I still have my 2x and my positive 3y up here, and that still equals 10. So now I'm going to combine what I can. I have 2x and negative 8x makes, careful, negative 6. There you go, negative 6x. Then I've got 3y and 4y make 7y, perfect. Now I've still got the plus 42 there, equals 10. So now the next thing I have to do is I have to get all the constants over on the right side, so I'm going to subtract 42. So that's gone. I've got a negative 6x plus 7y. 10 minus 42 is negative 32. So that is equation B after I've substituted in to get rid of the z. So z is gone in that equation now. So the only equation I haven't used yet is equation C. So that's going to be the next one I have to use. So equation C is 3x minus y minus 2z equals 1. Only I've got to replace the z here with 21 minus 4x plus 2y. Now that equals 1. Just like up above, there's nothing I can do inside the parentheses here, so I have to distribute. And it's a negative 2 this time that I have to distribute. So I've got negative 2 times 21. Negative 42, good. Negative 2 times negative 4x. Positive 8x, good. And negative 2 times 2y. Negative 4y, good. That equals 1, and I have my 3x and my minus or negative y up front yet. So just like up above, we're going to combine what we can. So I've got 3x and 8x make 11x. Think of this as a negative 1y. So I got negative 1y and negative 4y make negative 5y. Yep. I still have that minus 42 here equals 1. So my final step, I'm going to add the 42 to get rid of the negative 42. So I've got 11x minus 5y equals 43. So that's equation C. So you can see now I have equation B. I got rid of the z variable. And equation C, I got rid of the z variable. So what I have here is a 2-variable, 2-equation system, like we were dealing with before. And so now this is what I have to solve, is this system here. So I've reduced it down to 2 variables, 2 equations. Well, I have to get rid of one of those variables. Either have to use substitution or elimination. Looking at it, neither one's going to be really easy. But what I'm going to do is I'm going to take equation C here and I'm going to solve it for y. So I am going to go ahead and we're going to subtract the 11x. So that's negative 5y is what's left there. 43 minus 11x is 43 minus 11x. Now to get y by itself, I have to divide by negative 5. I'll divide that whole thing by negative 5. So the negative 5 here is gone. Y equals, well, 43 divided by negative 5 is a negative 8.6. Negative 11x divided by negative 5 is a positive 2.2x. So that's equation C that I solved. So I have to go back and use that in equation B. So equation B, negative 6x. I need more room here, I think. We've got negative 6x plus 7. I'm going to replace y with the negative 8.6 plus 2.2x. That's going to equal a negative 32. Now this is going to get a little ugly here because we got some decimals, but not too bad. So we've got negative 6x isn't going to change, but we've got 7 times a negative 8.6. What's that give us?
60.2.
A negative 60.2. Good. And then 7 times 2.2, x?
15.4.
15.4x. Good. That equals the negative 32. So now I'm going to combine. I have negative 6x and 15.4x. Well, 15.4 and negative 6 make 9.4x. Good. Minus 60.2. equals a negative 32. So now we have to add the 60.2. So negative 32 plus 60.2 gives us what? $28.2. Good. And then finally, we have to divide by 9.4. 28.2 divided by 9.4 is 3. We get x equals 3. So now that I have x equals 3, I have to go back and find my other variables. I have to go back to the 2-variable system here. I can use either one of those now that I know that x equals 3. I'm going to use equation C. I'm going to use the bottom one there. In fact, I'm going to use this version right here because I've already got it solved for y. Y is equal to negative 8.6 plus 2.2 times x, and x is 3. So to solve that, negative 8.6 won't change. 2.2 times 3 is
6.6.
6.6. Good. And we will add negative 8.6 plus 6.6 gives us come out to negative 2.
Yeah.
Perfect. So we've got x equals 3 and y equals negative 2 so far. Now we have to go back to one of the original equations to find z. I'm actually going to go back to this equation here, the equation A that I had solved for z. So z equals 21 minus 4x plus 2y. And I'm going to put in the values I have for x and y. So z equals 21 minus 4x becomes 4 times 3 plus 2y becomes 2 times negative 2. So we got 21 here. 4 times 3 is 12, so minus 12, yep. And then 2 times a negative 2 is
4.
yeah, negative 4. Good. So now we're going to take 21 minus 12. Is 9. And 9 plus that negative 4 is 5. So our solution, x is 3, y is negative 2, z is 5. Any questions on that? I know it's quite a long process. Now, I'm going to give you guys a little hint. For those of you thinking this is not something you really want to do on a test or a quiz, there is going to be a quiz at the end of the day Friday on these systems of equations. But I will tell you, every equation that's going to be on that quiz will be done in class at some point before that quiz. So just so you're ready for that. So let's take a look here at another system. So let's do, my computer's been acting funny all day. Okay, so let's try 2x plus y minus z is going to be a negative 1. 3x plus 2y plus z is 8. And let's do x plus 3y plus 2z is 17. So now again, I'm going to label this system of equations A, B, and C. Now I can do substitution here. I can see that equation A would be really easy to solve for y. Equation B would be pretty easy to solve for z. Equation C would be pretty easy to solve for x. So I'll let you guys pick. Which variable do we want to solve for? Z? Okay. We're going to solve for z in equation B. So equation B here, 3x plus 2y plus z equals 8. I have to get z by itself here. Now last time I did it the long way, I removed each piece by itself. I can do both of them at once if I want to. I have to get rid of the 3x and the 2y, and they're both added. So I'm going to subtract 3x from both sides. And I'm going to subtract 2y from both sides. Just saving a step. So those are both gone, leaving me with z equals 8 minus 3x and minus 2y. So that's equation B after I solved it, rearranged it to be z equals. So now I've used equation B, I have to use the other two. So let's use equation A first. So I'm going to take equation A, it's 2x plus y. Now I have to be really careful here. That's minus z, but remember I'm going to replace z with this over here, the 8 minus 3x minus 2y. So it's minus, and in parentheses I'm going to put 8 minus 3x minus 2y instead of the z equals a negative 1. So now just like before, we're going to go solve this, or rearrange this, I should say, simplify it. So in our parentheses, there's nothing to do. It looks like there isn't anything to do to the parentheses, but what do we have to do?
You have to make negative changes and positive changes.
Perfect. And the easiest way for me to think about that is to think of this as a negative 1, and we're just distributing a negative 1. So negative 1 times 8 is negative 8. Negative 1 times negative 3, or negative 3x? Positive 3x, good. And negative 1 times negative 2y? Positive 2y, good. And that still equals negative 1, and we still have the 2x and the positive y up front. So now I'm just going to rearrange. I have 2x and 3x makes 5x. I have y and 2y make 3y. And now I'm going to save a step here. I have to get that negative 8 out of there. I'm going to add 8 to get rid of that. I'm going to add 8 over here. Negative 1 plus 8 is 9. So there it is. The equation A has been solved, has been reduced to 5x plus 3y equals 9.
That should be positive 7.
That should be a positive 7. Very good. Thank you. So it's 5x plus 3y equals a positive 7. Good catch. So now the equation I haven't used yet is C. So let's use equation C here. X plus 3y plus 2. Instead of z, we're going to use 8 minus 3x minus 2y. That equals 17. So let's go ahead and multiply through, distribute the 2. 16. I'm going to put a plus in front of it since it's positive. 2 times negative 3x. Negative 6x. And 2 times... And minus 4y. Very good. 2 times negative 2y is minus 4y. So we still got the equals 17, and we have x plus 3y up front. So again, we're going to go combine. We've got x and a negative 6x make
5x.
negative 5x. Good. And 3y and a negative 4y?
Negative 1.
Negative 1y, or just minus y. And now I'm going to get rid of the 16. I'm going to subtract 16. So 17 minus 16 is 1 on the other side. So equation C has become negative 5x minus y equals 1. So what I'm looking at this point is solving a system for this 5x plus 3y equals 7. Negative 5x minus y equals 1. Now at this point, since we used substitution in that first step to get it down to 2 equations, there's no saying that I have to use substitution again. I have 2 equations, 2 variables. I can use whatever method I want to solve that system. Looking at this one, this is very easy to solve by elimination. It's already lined up with x's, the y's, the equal sign, and then our constant number. So it's already lined up. And if we add down our columns, we have positive 5x and negative 5x. So that's going to disappear on us. So 5x and negative 5x cancels out. 3y and negative y?
2y.
2y. And then 7 and 1 is 8. So we're going to just divide by 2 to get y equals 4. So we have y equals 4. Now I have to go back up through and find the other variables. So I go back up to this set here, 2 equations, 2 variables. I put 4 in for y in either one of the equations, and I find x. I'm going to use the top one here because there's no negatives. So 5x plus 3 instead of y, I'm going to put in 4. So 3 times 4 equals 7. So 5x plus 3 times 4 is 12. What am I going to do next here to solve this equation? Subtract 12. Very good. So 5x equals a negative 5. And then? Divide by 5. Good. So x equals negative 1. So we've got x equals negative 1 and y equals 4 so far. So now we go back up to the original equations. And I could use any of these original equations to put x and y in to find z. But remember, we've got this one here that we already solved for z. Z equals 8 minus 3x minus 2y. Z equals 8 minus 2x minus 3x minus 2y, I think. So I put those values in. So 8 minus 3 times, it's going to be negative 1 for x, minus 2 times 4 goes in for y. Order of operations tells us what do we have to do next here? Yeah, we can either do 3 times negative 1 or negative 3 times negative 1. I'm going to treat it as a negative times a negative and get a positive 3. Now, next thing I have to do, negative 2 times 4 is a negative 8. So 8 plus 3 minus 8. And now it's just 8 plus 3 is 11. Minus 8 is 3. So that's telling us here that z equals 3. So x is negative 1, y is 4, and z is 3. So you can see we used substitution in the first step. Then in the second step, we went back to using elimination or addition. So you can mix or match these methods depending on what's going to work easiest with our system of equations. Now, substitution has its strength when one of the equations is missing one or more of the variables. For example, you may have a system of equations that looks something like this. Three x plus 2y plus z equals 4. 5x minus 2z equals 2. And 3z equals 12. So I'm just going to label these equations A, B, and C. Well, in looking at this, it is a system of equations, but it's not a very difficult system to solve because equation C here has only one variable, only has variable z in it. Just because we have a 3-variable system of equations doesn't mean that every equation has to have all 3 variables in it. So here, since equation C only has one variable in it, we can solve that for z. How would we solve it for z?
Divide by 3.
We divide by 3. So we get z equals 4. Perfect. So we got z equals 4 right away. Now we can use that in the other equations. Now up here, this equation has the variable z in it, and x is the only other variable. Y is missing. So if I use that in there, it should get rid of z and give me x. So 5x minus 2 times z becomes 2 times 4 equals 2. So that's 5x. What's negative 2 times 4?
Negative 8.
Negative 8 equals 2. Then what?
Add 8.
I add 8. So 5x equals 10, and then
Divide by 5 and x equals 5, or 2.
perfect. I divide by 5, and x equals 2. So I've got x and z. Now I can go back to that first equation. Equation A. 3x becomes 3 times 2, plus 2y, we're going to leave that, plus z is going to become 4. That equals 4. So then, we got to find y. I'm going to combine. 3 times 2 is 6. Then I'm also going to combine. The 6 and the 4 are being added to make 10. So 10 plus 2y equals 4. What's next? Subtract 10. 2y equals, what's 4 minus 10? Negative 6. Good. And finally, our last step.
Divide by 2.
Divide by 2. So y equals negative 3. Good. So we've got x is 2, y is negative 3, and z is 4. Any questions there? Okay. Now we might have one that looks something like this. X plus 3y minus z equals 7. 2x minus y minus 3z equals 9. And 3x plus 2y plus z equals, let's see here, equals 6. Looking at this system here, I'm going to label them again, A, B, C. This here is a system where it would be really easy to solve for either x in the first equation or z in the last equation. Now, since it's just a negative, it wouldn't be too bad to solve for z or y in these equations either. But I'd stick with the positives. It makes less mistakes that way. But let's switch a little bit here. Rather than doing substitution in this one, we're going to do the elimination or the addition method. So to do elimination or addition method, we can only combine two equations at a time. And we're going to have to do that twice. The key is the first time we're going to do it, we're only going to use two of the equations. The second time, we have to use the third equation and then one of the first two. So if I look at this, I am going to add equation A plus equation C. The reason I'm going to do that, once I write them together here, it might be obvious. When I add those two equations together, one of my variables is going to disappear. Which one is it? Z is going to cancel out. Good. So let's do the x plus 3x is 4x. 3y plus 2y is 5y. Negative z and z cancel out. Equals 13. Very good. 7 plus 6 is 13. So that's equation A plus C there. You'll notice it is a two-variable equation. So that's one of my two-variable equations for my two-variable system. Now there's two things that have to happen next. One is I have to use equation B because I haven't used it yet. The second thing that has to happen, what variable did I eliminate the first time here? Z. So I have to eliminate the variable z again. So here's what I'm going to use. I'm going to use equation B. I'm going to write that down. And I'm going to use equation C to eliminate variable z. But if I just add z to it if I add equation C to it, is the z variable going to disappear? No. So what do I have to do to equation C? I'm going to multiply the whole equation by 3. So now 3 times 3x is 9x. 3 times 2y is 6y. And here's why we chose 3. 3 times z is positive 3z. Very good. Equals 3 times 6 is 18. By multiplying the equation C by 3, that gives me a positive 3z. Now it's going to cancel out the z's. Remember, that was our two requirements. We had to use equation B, and we had to cancel out the z again. So we have 2x plus 9x makes 11x. Negative y plus 6y. 5y, positive 5y. The z's cancel out again. Equals 9 plus 18. 27. Good. So this is equation B plus 3 times equation C. So there is my second two-variable equation for my two-variable system. So you see I've got two equations here both of them have just the variables x and y. So I am going to use them now as a system of equations. So I'll just bring this one down here. A plus c, 4x plus 5y equals 13. Well, looking at this, it's become apparent that I am going to multiply one of those equations by a -1. So I'm going to leave the top equation alone. 11x plus 5y equals 27. I'm going to multiply this one by -1. Why am I going to multiply it by -1? Perfect. So that's a -5y, and then the y's will cancel out. So -1 times 4x. -4x. -1 times 5y. -5y, yep. Equals -1 times 13. -13. So now on this system, I'm going to go ahead and add them to get rid of the y's. So 11x and -4x make 7x, very good. 5y and -5y cancel out. And 27 and -13. 14, good. So now we have 7x equals 14. We'll divide by 7. X equals 2. So now we got to go back through and find y and z. So I go back to my two variable system here first. I'll put x into one of them. Let's just use the bottom one here. 4x becomes 4 times 2 plus 5y equals 13. So 4 times 2 is 8 plus 5y equals 13. We're going to subtract the 8. 5y equals 13 minus 8 is 5, and then what? Divide by 5. So y equals 1. So we've got x equals 2, y equals 1. I go back up to one of the original equations, and I use x equals 2, y equals 1 to find z. I'm going to use this one right here. So 3x becomes 3 times 2. 2y becomes 2 times 1 plus z equals 6. 3 times 2 is 6 plus, I'll just do it all at once here. 2 times 1 is 2 plus z equals 6. What would I want to do next?
Add the 6 and 2.
Add the 6 and 2 to make 8. So 8 plus z equals 6. And now the last step will be subtract 8. So z equals a -2. So my solution here, x was 2, y was 1, and z is a -2. Okay, it's time for break. So go ahead and take about a 3-minute break. And we'll come back and we'll pick her back up.
Yes, sir.
So we've got a system that looks like this. This one here is not quite as simple as the example we did a couple ago, but it's pretty simple. Or at least a lot more simpler than some of the others we've looked at. We look at this one and we see again that bottom equation, equation C, only has the variable x in it. So we can solve that one right away for x. So what are we going to do? Divide by 5 to get that x equals 4. Perfect. So now we can take that up and we can use it in the original two equations to replace x. So in equation A up here, 3x becomes 3 times 4 plus 5y plus 2z equals -1. Now I can do the 3 times 4 is 12. And then I'm going to go ahead and subtract the 12 to get the y and z on the left side by themselves. I want to get all the constants or the whole numbers over to the other side. So I subtract 12. I subtract 12 there. So 5y plus 2z equals, what's negative 1 minus 12? Oops, careful. Negative 1 minus 12 is a negative 13, right? No, it's not minus negative 12, just minus 12. Negative 13. There you go. Okay. Now we got to do B. So equation B is going to be 2x. Well, that's going to be 2 times 4 again. Minus 3y minus 3z equals 14. So I'll do the 2 times 4 is 8. And then I have to subtract the 8 to get the y and the z by themselves on the left side again. So equation B is going to be negative 3y minus 3z. And what is 14 minus 8? 6. So I have these two equations. So I'm going to write them back over here. Oops. That's B, not C. Now, I could just proceed as normal with these and, solve one of them or whatever. But when I look at this system here, specifically this bottom equation, there's something I can do that'll make this a lot simpler for us. What I can do down there is I see that every number there, 3, 3, and 6, each one of them can be divided by 3. In fact, I'm going to make it simpler yet because it's a negative 3 and a negative 3. I'm going to divide each of them by a negative 3. So I'm going to divide this whole equation by a negative 3. So negative 3y divided by negative 3 is just 1y, or just y. Negative 3z divided by negative 3 is just 1z, or just plus z, equals 6 divided by negative 3 is a negative 2. So equation B can reduce down to y plus z equals negative 2. So my equation A is still 5y plus 2z equals negative 13. So now looking at this, it's a lot easier to deal with this equation than it was up here because I've got just 1y and 1z. I can either solve it for one of them and use substitution, or I prefer to go for elimination. I'm going to multiply this equation again by, what would I multiply it by to eliminate one of my variables? Negative 2 would eliminate the z. Perfect. I could have also multiplied by negative 5 and it would have eliminated the y. So negative 2 times y is negative 2y. Oops. Nope, I'm multiplying right here. Negative 2 times just y. So negative 2 times z is negative 2z equals negative 2 times a negative 2. Positive 4. Perfect. So now I'm going to add these two equations together. So 5y plus negative 2y is 3y. 2z and negative 2z make cancel out. Perfect. Equals negative 13 plus 4. Negative 9. So our next step.
Divide by 3.
Perfect.
Y
So-
equals -2.
Perfect. So we divide by 3 and y equals a negative 3. So I go back up to either one of these two variable equations I had. Actually, I'd probably go to this one here. Y plus z equals a negative 2. Now I'm going to replace y with negative 3. Negative 3 plus z equals negative 2. Now I'm going to solve for z. So it's a negative 3. I'm going to add 3. What's negative 2 plus 3? 1, yes. So we have, up above here, we had x equals 4. Y equals negative 3. And z equals 1. There we go. Okay. We might run into one like this. I don't know why I'm writing so big here. I'm going to try that again. Okay, so we've got negative x plus 3y minus 2z equals 7. Answer yourselves, guys. We've got 3x plus 4y minus 7z equals a negative 8. And we've got x plus 2y plus z equals 2. So again, I'm going to label these equations A, B, and C. Now this one we could solve by either method. We could either use elimination or we could use the substitution. I want to do elimination again. Looking at these, is there any variable that would be easy to eliminate?
Probably the positive x.
Probably the x, exactly. Looking at here, if I combined A and C, the x would disappear in those. Then coming back for B, I could use the negative x and I can multiply a little bit to get rid of it. So let's get rid of x. We're going to eliminate x. So I'm going to add equation A and equation C. So A is negative x plus 3y minus 2z equals 7. Equation C is x plus 2y plus z equals 2. I add those together. Negative x plus x is gone. It cancels out. 3y plus 2y is 5y. Negative 2z plus z.
Negative 1z.
Negative 1z or just negative z. And 7 plus 2
9.
is 9. So there I have one equation already where I've eliminated the x variable. I used equations A and C. That means this time I have to use equation B. And again, I have to eliminate the x. So what I'm going to use there, I'm going to use equation B. 3x plus 4y minus 7z equals negative 8. Now, since that's a positive 3x, I need a negative 3x to go with it to cancel it out because I have to eliminate the x. Well, looking up here, I could use equation A times 3 would give me a negative 3x, or equation C times a negative 3. Well, in order to keep it positive, I'm going to do 3 times equation A. So I'm going to multiply it by 3 here. 3 times the negative x is the negative 3x. What's 3 times 3y? Positive 9y. Good. 3 times my negative 2z. So negative 6z. Good. And 3 times 7? 21. So, okay. So, now we're going to go ahead and add the columns here. 3x and negative 3x cancel out. 4y and 9y. 13y, good. Negative 7z and negative 6z make, careful, negative 7 and negative 6 make negative 13z. Then we've got negative 8 and 21. What's negative 8 plus 21? 13. So that's b plus 3a. Now when I look at this one, again I see that every number here is 13. So I can reduce this one by dividing by 13. So 13y divided by 13 is just y. Negative 13z divided by 13 is negative 1z, or just negative z. And 13 divided by 13 is 1. So I have that, and I have this one here. So I've got 5, I'll put it down below. 5y minus z equals 9. And I have y minus z equals 1. So now looking at this, the z, I have a negative z and a negative z. So I could easily alter that so I could get rid of the z's. I'm going to keep this top equation. I'm going to multiply this bottom equation by what? Not positive 1, but negative 1. So negative 1 times y is negative 1y, or negative y. Negative 1 times a negative z. Positive z, good. And negative 1 times negative 1? Negative 1. So we add those two equations. 5y plus a negative 1y is 4y. Perfect. Negative z plus z cancels out. Equals? Perfect. 9 plus negative 1 is 8. So then all we have to do to find y is divided by 4. So y equals 2. So now I have to go back and find z. I have y minus z equals 1. So if y is 2, 2 minus z equals 1. I have to solve that. Now some of you might be able to just look at that and see that, well, z has to be 1. Well, let's solve it the long way, the formal way. We're going to subtract 2. Gives us negative z equals 1 minus 2 is a negative 1. And then we will divide by the negative 1. So z equals 1. So we have y equals 2, z equals 1. We have to go back up to one of the original equations to find x. I'm going to use this one right here. X plus 2y plus z equals 2. But we know that y equals 2, so this is x plus 2 times 2 plus z we know is 1 equals 2. So now it's just a matter of order of operations and combining some stuff here. So x plus 2 times 2 is 4. 4 plus 1, 5. So x plus 5 equals 2. What's next? Subtract 5 to get x equals negative 3. So x is negative 3, y is 2, and z is 1. There is our solution. Any questions? Okay. Well, there's another kind of weird thing that can happen with these systems. We might run into something like this. Okay, so for this system here, again, I'll label them A, B, and C. The equation C does not have a z variable in it. So we have to figure out what to do with it. Well, if we look at this carefully, though, we see, first of all, that all these equations have a 2y in them. So I could very easily eliminate the y's just by multiplying one of them by 1, or negative 1. So here's what I'm going to do. I'm going to start out with equation A. X plus 2y minus z equals 2. And I'm going to add to it negative 1 times equation C. So that's going to turn the 2y to a negative 2y. Well, what is x, negative 1 times x is what? Negative 1x, right? Or just negative x. What's negative 1 times 2y? Negative 2y. Now there is no z there, so I'm just going to leave the z spot blank. Equals, what's negative 1 times 3? Negative 3. So let's try to add the columns here to eliminate. X and negative 1x cancel. Perfect. 2y and negative 2y cancel out. Well, negative z and nothing is just negative z. 2 and negative 3 is just a negative 1. So what I have here is a negative z, or I think it was a negative 1z equals negative 1. So I divide by negative 1. Z equals 1. It does happen occasionally when you go to solve a system of equations that two variables disappear. So in this case, that saved us some work. We got z equals 1. Now we still have to go back. We used equation A and C. We still have to go back and use equation B. And in equation B, we still have to eliminate the y variable. So I'm going to use equation B. 3x plus 2y minus 5z equals 6. Then I'm going to use this equation here, the negative 1 times c that I used before. So that is a negative 1x minus 2y, there is no z, equals negative 3. So I just recopied this from up here. So now let's add the two equations together. What is 3x plus negative 1x? 2x. 2y plus negative 2y. Cancels out. Negative 5z doesn't have anything to do with anything else. 6 plus negative 3 is 3. Now we're thinking, there's our system, or there's an equation with two variables. We're thinking, where's our other equation with two variables? Well, in our other equation, the second variable disappeared, so it left us with just z equals 1. So now we can go ahead and go back through using the z equals 1. We can go to this equation here, put 1 in for z, so 2x minus 5 5z becomes 5 times 1. Five times 1 is 5, so it's minus 5. Now what do we do? Add 5 to get rid of the minus 5. So 2x equals 8. Then what? Divide by 2. X equals 4. So we've got x equals 4 and y equals 1 here. We just need to find z. I go back up to any of my original equations. Well, this one doesn't have z in it, so that ain't going to work to find z. So I have to use one of the first two equations. Doesn't matter which one, so I'm going to take the top one. X plus 2y minus z equals 2. And I know that x is 4, so put in 4 there, plus y is 1, so this is 2 times 1, minus z equals 2. Well, I know 2 times 1 is just 2. I know what happened there. I'm going to rewrite that so I can actually read it. Here we go. So now we have 4 plus 2 is 6. So 6 minus z equals 2. What's next?
Minus 6.
Subtract 6. Very good. So negative z equals negative 4. Then what? Well, we treat that as a negative 1z. So to get z by itself, we have to get rid of the negative 1. We're going to divide by negative 1. Very good. So z equals 4. So x is 4, y is 1, z is 4. 4, 1, 4 is our solution. What do you think? Not so bad? Okay. Now, there are electronic ways of solving these. Graphing calculators, by the way, have a function built in for solving systems of equations. But the electronics, the software that does it, the calculators that do it, they all work off of something called a matrix. Now, this has nothing to do with the movie. All a matrix is an organized set of numbers. So we might have like 4, 3, negative 2, 0. Oops, I don't want to put commas in there. I gotta get those out. 0, negative 5, and 1. Put them in brackets. That's a matrix. The position of the number in the matrix has a meaning. At this point, we don't know what the meaning of these numbers is, but it's just a generic matrix. But we can define some of the characteristics of the matrix. First of all, the matrix has rows. This would be row 1. This would be row 2. So this matrix has 2 rows. Matrix also has columns. So this would be column 1, 2, and column 3. So if I were to define this matrix, it would be a 2 by 3 matrix. We define the number of rows by the number of columns. If we have a square matrix has the same number of rows as it does columns. So the rows equal the columns. And in a square matrix, there's something special we can do. So a square matrix might look like this. 3, 7, negative 1, 4. In a square matrix, we can do something called a determinant. And what a determinant is it's a way of summarizing all the numbers in a matrix and their positions with a single number. So a determinant is found using diagonal products. in a 2 by 2 square matrix, which is what I have here, we use one down product The down diagonal product starts in the upper left corner and goes down. 3 times 4 is what? 12. That's our down product. And we use an up product. So we start in the lower corner and we go up. What is -1 times 7? -7. So that is our up product. In a 2 by 2 diagonal matrix, the determinant is equal to the down product minus the up product. So the down product is 12 minus the up product is a -7. So 12 minus the -7 is a 19. So the determinant of that matrix would be a 19. Well, why do we care? Why is that an important value for us? Well, these determinants, first of all, they're how calculators and computer programs see these matrices and numbers. But these determinants can actually be used to find the solution to a system of equations. We have to make several matrices out of a system to do it, but let's take a system, a simple system like this. Let's say we've got 3x, oops, let me put this in black. 3x plus 2y equals 13. I'm just going to go back to 2 variables for now. 2x minus 3y is also going to be 13. For this matrix, or for this system of equations here, I'm going to define 3 matrices. There's something called a base matrix. The base matrix is just the coefficients of the variables, the x's and the y's. So it's literally the coefficients of the x's first. So I've got 3 and 2 here. It's not x variables. The coefficients of the y's goes next. That's 2 and -3. There's my matrix. So the determinant of that matrix would be pretty simple. What am I going to start out with? Yep, I go to the down diagonal. 3 times -3 is -9. And then what? 2 times 2 is my up diagonal is 4. So my determinant is -9 minus 4, which is -13. Well, how does that help us? Well, we have what's called an X matrix. In an X matrix, the computer would replace the X variables with these constants here. So instead of the X variables, we put in the constants. So that's going to be 13 and 13 there. Then we still have the Y variables, the Y coefficients in the next column. So 2 and -3. That makes that matrix. So to define that determinant, what are we going to do? 3 times -3 is -39. And then 13 times 2 is 26. So this is a -39 minus 26, which is a negative, was that -62? I don't know where I got the 36 there. That should be a -39, sorry. -39 minus 26 is a -65. There we go. That's my X matrix. There's also a Y matrix. In the Y matrix, we replace the Y values with the constants. So in the Y matrix, we have the X values. It's the Y values that get replaced. So the X values are 3, 2. And the constants are still 13 and 13. So let's do our diagonals. We've got 3 times 13 is 39. 2 times 13 is 26. So the determinant here is 39 minus 26, which is 13. Good. Well, what do all these numbers do for us? The value of x is the determinant of the X matrix divided by the determinant of the base matrix. So the X matrix was negative 65. The base matrix was a negative 13. What is negative 65 divided by negative 13? 5. Good. Positive 5. The Y, the value of Y is the determinant from the Y matrix divided by the determinant from the base matrix. So the determinant from the Y matrix was positive 13. The base matrix was still a negative 13. 13 divided by negative 13 is negative 1. So the solution here is x is 5, y is negative 1. Now if we get time before our final test next week, we'll look at using this for 3 variable systems. To do that, you'd have to do 3 by 3 square matrices. That determinant's a little more difficult to do, a little trickier. Yes, sir, do you have a question?
Did you say our final is next week?
Yep, we have a final test that is coming up next week, Friday.
Our class final.
Our class final, yep.
This Friday.
Next week, Friday. On the 12th. We have a quiz this Friday, but we have a final test then next week, Friday. Yeah, well, kind of, because it's hard to separate everything out. It's mostly on the materials from the last 7 weeks, the stuff from spring break, but a little bit from the whole semester will be on there. I tried to be nice. How much is a passing grade going to cost? Put it this way, for what it would cost to get a passing grade, you can hire a lot of tutoring. Okay. I have faith that all you guys can do just fine on the test. You guys have done really well this year. So, there's a worksheet with 3 variable systems on it for you guys to do. Did you get a chance to copy that off, Mr. Berghammer? He's not there? Okay, I sent it really late, so. I'm just going to give you guys 2 of them to work on here. So the first one, x plus y plus z equals 6. X minus y plus 2z equals 5. And 2x minus y minus z equals negative 3. So that's your first one to work on. And then number 2, 3x plus y minus z equals 2. X minus 2y minus 2z equals 6. And 4x plus y plus 2z equals 7. 2 of them is probably enough to do for homework anyway, since these are long problems. So those are your 2 problems for homework for Friday. Like I said, on Friday we'll go over this stuff a little bit more again, and I'll show you some applications of where this is used in construction and some other things. If there's time, I might even show you how it's used in material science and separating metal alloys. Systems of equations are a very powerful tool when it comes to doing anything engineering related or building related. I've used system of equations, and when I was working as an engineer, I used them a lot. Okay, I'll let you guys have the last 5 minutes to get started working on those two problems. You guys have a great day. We'll see you on Friday.